Hey guys, so what we're going to be looking at today are the power rule. I was trying to underline that, did not quite manage to do that. Power rule and derivative rules. Okay, so 2 lectures ago now, what we did was we looked at the definition of the derivative and what we could do with that. What we're going to do in this lecture is throw away the definition of the derivative and not use it again. Okay? So you learned it, now it goes away forever. So you learned the definition of the derivative. I just said the definition of the derivative. There's more words there. Of the derivative. Now let's get rid of it. Right? How are we going to do that? Well, we're going to learn a bunch of shortcuts for derivatives. Now, the first step in doing that is to learn some basic rules of derivatives. Okay, now I'm going to write some rules here, and we're going to have to learn that they are true. Okay, so we'll prove some of them, not all of them. Okay, so here's some basic ideas. So what we need is functions that have derivatives at a point. Okay, so we're going to assume that, I'll write that a little nicer. Assume that, let's say, f prime of a and g prime of a exist. Okay, that's it. So we're just assuming that there's two functions that have derivatives, basically. Okay, now here's some, what else do we need? One more thing. We have those. Let's also assume that, what do I need? Let's just say k is a constant. And k is a real number. That's all, which means this is not a period. Okay, that's what we need. Now what are we going to do with it? So here are some rules for derivatives, just how they behave, okay? So we got rule number 1. If you want to, how am I going to write this? Oh, that's annoying. I guess I'll write it with, it's a little bit tricky. So I'm going to use some notation for the derivative that you haven't seen before, but I'll write it right here, and that'll have to be good enough. And also I'm going to come up here and erase these, and I'm just going to say f prime of x, g prime of x exists. Okay, that'll be okay. So this notation, the d over dx, whoa, that was an email. D over dx means the derivative with respect to x and then of, right? The idea is you write d dx, and then whatever you put in these parentheses here is what you're taking the derivative of. And if you change the x to another variable, then you would be taking the derivative with respect to another variable. So d dx just means the derivative with respect to x. Okay? Now, if we do this for f of x and plus g of x, then it turns out that what happened is that's the same as just taking the derivative of f and taking the derivative of g. Now, what that's saying is that you can just take the derivative of two things separately. We'll see examples of all this, so don't worry. Of course, subtraction and addition are basically the same thing. So if I put a minus there, you can probably guess that that would just be f prime minus g prime. Another rule would be that if you have the derivative of a constant times f of x, that you can just say that that is the constant times, well, I'll write this in 2 lines, constant times the derivative of f. So you can think of that as taking this constant and moving it out front. And then when you take the derivative of f, you get f prime. Okay. Now what else? So we have addition, we have subtraction, we have rule 3, which we call scalar multiplication. What else do we need? Well, we can't have multiplication and we don't have derivatives yet. Okay, so what I am going to put here are, did I say we don't have derivatives yet? We don't have multiplication or division yet. So we don't have those on the list, but we have what we have and 2 more things. And these rules are going to be important for what's coming after this. So ddx of what? If I take the derivative of a constant by itself, the derivative is 0. And if I take the derivative of, I'm going to say like, I have a k as a real number. I'll say kx then, so I don't have to define a new one. The derivative of kx is just going to be k. All right, so that's where we're going to start. I'm going to leave a little bit of space here for the power rule. Okay, and that one's going to be important, but I don't want to write it yet. So I'm going to come back here and write it. Let's prove a couple of these rules just to convince ourselves that they're true, and then we'll do some stuff with them. All right, so let's prove one of these. Let's prove the first one, okay? Let's see. Prove that the derivative of f of x plus g of x is equal to f prime of x plus g prime of x. Okay, so how do you do that? How do we prove one of these rules? So what you do to prove one of these rules is you're going to have to start with the definition of the derivative. So if I say the derivative of f of x plus g of x, that would be, according to the definition of the derivative, the limit as h goes to 0 of f of x plus h plus g of x plus h. That's your equivalent of just f of x plus h, because we have 2, so we have to put them both in, minus f of x plus g of x over h. Right? That's what the definition would say. Well, if you just work out what you have there in the numerator, you can rearrange it and have f of x plus h minus f of x from this and this, plus the minus, and, from the g and the g, you could have, what color is I using? This one? Plus g of x plus h minus g of x over h, but you can split that up into 2 limits using rules for limits that we learned, didn't spend much time with, but we did technically learn some limits. So you can split that up into 2 limits, and then when you do that, like this entire limit here, you should recognize as that entire limit is just f prime evaluated at x. Normally you see that with an a, but not this time. And then this entire limit is simply g prime of x. Okay, and so there you go. So that's how you prove these, where this is actually this. All right. Do we want to prove a different one? I guess the only other one, I don't want to prove them all. It'll take a long time. We can just use the rules. I probably want to do one of these. Which one should I do? well, we can do both. They're both pretty easy. Let's prove 4. Prove 4, which was, what was it? ddx of a constant is 0. Was that right? I think that's right. Okay, so basically we're going to use this. So imagine f of x is just k, where k is a constant, right? Then the derivative of k in that case is, just f prime of x, which is, of course, the limit as h goes to 0 of f of x plus h minus f of x over h. Now the thing is, we've got a function here, an f of x, where the function is just k. So what is the f of x plus h? It's k. What is the f of x? It's k over h. So it's just the limit as h goes to 0 of 0 over h, which is the limit as h goes to 0 of 0, which is 0. All right, so it's just such a very basic thing here. So this derivative is 0, just like that. Let's prove number 5. Prove, I'll just write it, ddx of, what did we say, kx should be k. So let's try it. Again, I'm going to imagine, I don't know why I'm saying imagine instead of just let, but let g, okay, I guess we're using g. G of x equals kx. All right, so the derivative of kx in this case is g prime of x, which is the limit as h goes to 0, not x, h goes to 0 of g of x plus h minus g of x over h. You've done these before. We're going to be putting an x plus h in just for the x. So when you evaluate g of x plus h, it's k parentheses x plus h minus g of x, which is just kx over h. So then from there, what you've got is the kx plus h is kx plus kh minus kx over h. The kx cancels with the kx because we have a plus kx and a minus kx. So you have kh over h. You've done enough of these now to know that the h's are going to cancel, giving you the limit as h goes to 0 of just k. Well, h goes to 0, but k is just k. So there we go. So we have now discovered that the derivative of kx is k. All right? And you can do similar work for whatever ones up here we didn't do. So we did 1, 4, and 5. 2 and 2 is basically the same as 1, and 3 is I don't know, about the same. But there we go. Now, what can you do with this? Well, you should be able to apply this way. So apply the rules. Some examples. Example. Let's just say f of x is 7x plus 6. Find f prime of x. Okay, so here's how this works. You want f prime of x. So we're not going to write the definition anymore, okay? We're only trying to apply these rules. So this is how it should look. So you should say f prime of x. Well, f prime of x is the derivative. Remember, we're writing the derivative like this now. So the derivative of, and then whatever you put here. So what are we putting there? We are putting the function, which is 7x plus 6 right there. So how do we do it? Well, what you do is you are going to apply Rule 1. So Rule 1 says that you can split the derivative up into 2. Now, something I didn't do at the beginning, but maybe I'll do it right now. Oh, that's weird. It took one equal sign and not the other one. But something you can think about happening here is that the derivative of f of x plus g of x, when we want to split it up, you split it up like this if you want. I didn't put parentheses on the second one, but you get the idea, right? So you've got one derivative plus the other derivative, and then one derivative plus the other derivative. So we didn't really write it this way up until now, but it's useful down here. So what you can do is you can say, well, this derivative splits into two derivatives. One is the derivative of 7x, and then plus another derivative of 6. Okay, and that is by rule number 1. By rule 1. Now, by the way, the numbering for the rules is just the numbering that I wrote them down in. If you look in the book, they're not going to be numbered that way. Okay, so by rule 1, we get that. Now, what we want to do is we want to evaluate those two derivatives separately. So we want to evaluate the derivative of 7x. Well, how are you going to do the derivative of 7x? Well, that's this one, right? No, it isn't. Sorry. Erase. Erase. That's this one. Oh, no, don't erase that. Okay. Try again. This one. This one. What's the derivative of kx? Just k. So what's the derivative of 7x? Just 7. Now you have the derivative of 6. What's the derivative of 6? Well, the derivative of 6, that's going to be this rule, right? The derivative of a constant is 0. So down here, the derivative of a constant, 6, is 0. All right, and that's it. Answer 7. So that's easy. With a little bit of practice, you don't need to write that amount of work, right? Like, it doesn't take you very long to be able to say, if I say evaluate the derivative of, and I just put numbers here like 5x plus 3, you should just be able to go, well, this one's going to be, no, not 0. That one's going to be 5, and that one's going to be 0, right? When you take the derivative. And then you just write 5. That's how much work it should take once you understand the rules, okay? But you do need to understand the rules in order to do that. So in order to do this, this was from rules 4 and 5, we called them. All right. Now you can also apply these rules using, you can also apply these rules with numbers. So they'll give you numbers like this, and it's initially confusing because it's just too many symbols on the page. But here's an example straight from the homework. If f prime of 4 equals minus 4, and g of x equals 5f of x, what is g prime of 4? Question mark. All right, so you see what I mean about it, that being confusing because of too many symbols on here. So what you should do is you should say, well, what are we trying to calculate? Because that's what we should start with here. We're trying to find g prime of 4. So let's write that down to start with. G prime of 4, right? This is what we want. Now, we need a way to manipulate the symbol. So we need to figure out how we want to write this. What's another way to write g prime of 4? And so there's even one more thing that I haven't shown you about the notation for a derivative. So I know how to say a derivative another way. In order to, like, g prime, I could say this way. d dx, that means the derivative, right? The derivative. And the variable is x, the derivative with respect to x. So we have d dx. Now, what's the function that we're taking the derivative of? The derivative is of g, right? We're taking the derivative of g. So g is here is 5f of x. I mean, maybe I'll even write it just g to start with, though, just to illustrate something here. So what I wrote so far says the derivative of g, right? The derivative of g. But how are you going to write the 4? Where do you write the 4? In this notation, you would write the 4 like this. If you want to say at 4 or evaluated at x equals 4, you kind of just have to put it here, kind of like where a subscript would go. So you have the derivative of g, and then this would mean evaluated at x equals 4. And that notation is understandable. And I understand this is the first time you're seeing it, but I mean, this is kind of how we can do it. Now, how would we do it from here? Well, you say d dx. I'm going to use parentheses instead of brackets. I don't care. I mean, why not? D dx of 5f of x. So d dx of 5f of x. That's because that's what g is, right? If you use parentheses like this, they usually will draw a vertical line and then put their x equals 4 there. If you use square brackets, then they'll usually not put a vertical line. They'll just do it that way. So d dx of 5f of x evaluated at x equals 4. Okay, but then what's the derivative of 5f of x? Well, that's, remember how to do it, it's up here, right? When you do the derivative of a constant times a function, it's just a constant times the derivative of the function. So when you're trying to do the derivative of 5f of x evaluated at x equals 4, that's just 5f prime of x evaluated at x equals 4. Or just 5f prime of 4 when you plug in the 4. Which is, well, what's f prime of 4? They gave that in the problem. They said that f prime of 4 was negative 4. So you just come down here and say, well, f prime of 4 is negative 4 according to the problem. So the answer is negative 20. All right. So there's kind of like a lot of notation there, but I don't know. It is what it is. How did they write it? Yeah, they used they wrote it in a simpler way in their solution. Here's what they wrote. Maybe you'll like this better. They said g prime of 4 is, well, they know that since they wrote this, first of all, they said g prime of x. No, I'm erasing all of this. Erase, 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 erase. Erase. All right, here's what they wrote. They wrote, so this is an alternative way. They wrote g of x is 5f of x. So g prime of x is 5f prime of x. Okay? that's using the rules without really saying what the rules were. And then they said g prime of 4 is 5 f prime of 4, which is 5 times negative 4, because they looked up what f prime is, remember? This is minus 4. And then 5 times minus 4 is minus 20. So that's how they wrote it. That's fine. Maybe I should have written it that way too. But when they apply the rule for the derivatives here, it's not, as clear what rule they applied. This is where they apply, what rule number was it? If I look up here, rule 3 they apply right there. Apply rule 3. So that's how they wrote it. Maybe I'll write it that way from now on. Blah, blah, blah. H is F minus G. Okay. All right. So I think that's it for like the really, really basic rules. What we need to talk about now is the power rule. Now, I'll write down what the power rule is in a couple places. I have to scroll up to the top and write it there. But I'll write it right here too. And the power rule kind of sucks right now because it's the next lecture from now where we're actually going to prove it. Okay, we're not going to prove it right now because we need another rule that we don't have. But here is what the power rule says. It's going to say if what? So if n is not equal to 0, then actually is it true? No, it's not true. It's not true if n equals 0. Then the derivative of x to the n is, and here's what happens. You take this exponent, you write it down in front, and then you subtract 1 from the exponent. Okay? And this is the power rule. Power rule for derivatives, because we will learn a power rule for integrals later on. So power rule for derivatives. So the n goes there, and then you do that to the power. So very simple rule. I'll write it up here. d dx x to the n equals nx n minus 1. Okay. Let's apply the power rule. Examples. Evaluate. I want the derivative of x to the 4th. I want the derivative of x to the 7/3. I want the derivative of square root x. Okay, and I'm purposefully making some of these more complicated just to, well, I mean, mostly to let you know that it can be complicated. But these are all going to use the same rule. So they're not using any other rules other than the power rule here. So this first one is just to illustrate the basic way this works. So what's the derivative of x to the 4th? Well, look at the pattern. You take the power and it goes down in front. So 4x. And then what happens to the power? Well, it goes from n to n minus 1. So you just subtract 1 and that's it. That's all you have to do. Subtract 1 from the exponent. Subtract 1 from the exponent. So what's it going to be? Just 3. Right? Very easy. Now for all of the others, it's a little bit more complicated. Like if I want to do this one, x to the 7/3, you take 7/3 down in front, x, and you have to do 7/3 minus 1 for the exponent, right? You subtract 1. Well, that's a little bit harder to do because it's fractions, but you can do 7/3 minus 1, and if you do, you're going to get 4/3, right? You can go like off to the side. 7/3 minus 1 is 7/3 minus 3/3, which is 7 minus 3/3, which is 4/3. Or you could use a calculator. That would be fine too. Right? My point there was it works for fractions in the exponent. Okay, let's do the next one. d dx square root x. To do this, what you would have to do is say, well, wait, it's a square root of x. A square root is actually a power of 1/2. So you have to write it that way. d dx x to the 1/2. Then you can apply the power rule, 1/2 x, 1/2 minus 1, which is minus 1/2, and I didn't really leave room here, but if you want, like this is fine, by the way it's written there, that's fine. But you could do one more line of work, and you could write it this way, using properties of exponents and so on. How does it work for negative exponents? Same thing. You take the power down in front. So in this case, it's negative 3x. And then you have negative 3 minus 1, which is negative 3. I don't like the way that looks. Negative 3 x to the negative 4. Okay, and that's it. And you can do similar ones, negative exponents, when you have fractions. So like if I say, what's the derivative of, let's say, 1 over x to the 5, right? If you want to use the power rule there, you have to write it as d dx x to the minus 5. And then you can apply the power rule. Only then. So then you take the minus 5 down in front and subtract 1 from the power. After you do that, then you're free to write it back in the other form. Right? So the power rule is just this right here. The first bit of work and the last bit of work were just properties of exponents that you would know. Okay. So, there's just some examples. So what can we do there? The book asks kind of weird questions sometimes on these. I'm going to come up with one here. Blah. They really like those constant problems. They don't want to give me power rule problems. I'll just make up a power rule problem. Example. So here's one thing they do. Like they'll say, well, no, let's not do what they do. Let's do an easier one first. Let's say f of x is x to the 3 plus 5x squared. I want you to find f prime evaluated at 2, which hopefully that number is not too big. They don't seem to have ones like this for some reason. This is what I would be asking if I was picking the questions. All right. So how are you going to do this? So you're starting with what they give you. So you're starting with the function. F of x is x cubed plus 5x squared. Right? Now, we need the derivative evaluated at 2, but we should get the derivative in general first, and then we'll just plug in 2. So before we get the derivative at 2, forget the 2, let's just find the derivative. So let's just find f prime of x. So f prime of x is just the derivative of this function here. Okay, well, how are we going to do that derivative? That's why you learned all these rules, right? You have one rule, right? The derivative of a sum, that's like rule 1, right? 1. That rule says you can do the derivative of the first thing plus the derivative of the second thing. Okay? Then you have the rule for constant multiples. I think that's rule 3. The one that was like k f of x. So I'm going to leave this alone. And on the second one, we have a rule that says if you have a constant like this 5, you can just pull the constant out in front of your derivative. Like that. Once you have that, you do each of these derivatives separately. So you do this one, and then when you're done, you do this one. So what's the derivative of x to the 3? Right? That's power rule. So the power rule says you take the power, you move it down in front, and you subtract 1 from the power. And then on the other one, you've got 5, but then times you have x squared. What's the derivative of x squared? You take the 2 down in front, and you subtract 1 from the power. So you just get 2x. So our derivative is 3x squared plus 10x. That's the derivative. Now we need it evaluated at 2. So once we've got this, what we're able to do is we're able to say, well, if f prime of x is 3x squared plus 10x, then what is f prime of 2? That's just plugging in a 2. So you just go 3 times 2 squared plus 10 times 2. So 3 times 4 it looks like, which is 12, plus 10 times 2, which is 20. And so the answer is 32. All right. Now where you want to get to on these is a place where you don't write all of this work. Okay. All of that work there is too much work. What the work should look like as you get better is like this. So as you improve, right, here's what your work should look like. F of x is, what was the original? X cubed plus 5x squared. Right, here's what your work should look like. There's your first line. Your second line, you know that you can take the derivatives of each of these separate. So you just, in your head, you bring the 3 down in front, and you have 3x squared, right? You subtract 1 from the power rule. On the second one, you've got 5x squared, and you know that that's going to be, like you have the 5, and then you bring the 2 down in front, and then you subtract 1 from the power, right? The derivative of x squared is 2x. So in your head, though, you can just think like, well, I take the 2 and I'm going to bring it down in front, but there's already a 5 there. So you bring the 2 down in front, so that's going to turn into a 10. And then it's x to the 1. So like in your head, you just kind of do that one. So your first line, your second line, and then your third line is going to be plugging in the 2. Because that's what they actually asked for. And then you punch that into a calculator or do it in your head, and you get 32. Okay, so you want to hopefully get to this point pretty quickly, and you know that's what the homework's for. It probably won't happen instantly, but you want to practice it until we get it. All right, let's do one from the homework. I'm trying to make it give me a better question. Oh, okay, there we go. Here's a good one. Yeah, this one will illustrate why, the way they ask them is a little awkward here. They say let H be F plus G. And F is x to the 4, and G is 6x to the 3. And they say, what is H prime negative 3? All right. Here is what I would do. I would say, well, okay, so H is, they say, f of x plus g of x. But they told us what those are. So f is x to the 4th. So put that in for f. G is 6x cubed. So put that in there, right? So write this yourself, right? They didn't write this for you, but you write it. Then you need the derivative. So the derivative of h is, I'll write it this way, the derivative of x to the 4th plus 6x to the 3, which is, and then this is where you take the derivative using the power rule and your other rules, right? But, once you're okay with them, you don't write all the rules down. So what's the derivative of x to the 4th? You bring the 4 down in front, subtract 1 from the power. So the derivative of x to the 4th is 4x to the 3. For the other one, you have 6, and then the derivative of x to the 3 is 3x to the 2. Okay? There you go. Now, what are they actually asking for, though? They don't want that. They want a number. So they want h prime of minus 3. Right? So notice that the way I'm writing this, I have equal signs here and here. But then I don't have an equal sign out in front here, right? Because this is not, like what I'm writing now is not equal to the previous lines, because the previous lines were h prime of x, and now it's h prime of minus 3. So h prime of x and h prime of minus 3 aren't the same thing. So what I'm doing here is a new line of work. In fact, maybe I should even just write it on the next page here, because I'm right at a page break. So h prime of negative 3 is, that's plugging in a negative 3 into our answer. So 4 negative 3 to the 3 plus, I'll do the 6 times 3, that's 18. And then negative 3 to the 2. So work that out. On a calculator is going to be the easiest way, but in your head if you can, or on paper. So 4 negative 3 cubed is negative 27. 18 times negative 3 squared is 9. Yeah, so this is definitely a do it on a calculator type thing. Don't be a hero. Don't add it in your head. I can't add that in my head. There's no way. 4 times negative 27 plus 18 times 9 works out to 54. It's a number. So we write 54 in, we hit enter on the computer. Computer says we got it right because we're geniuses. All right. Let me skip this because it's too easy. Let's do a harder one. Oh, okay. Yeah. So they will eventually get harder. So here's one that I've got now on the computer. F of x equals 25x cubed over 3 plus 10x squared plus 4x minus 7. Oh my goodness. They say find all x values where y equals f of x. Well, they just say f of x, where f of x has a horizontal tangent line. All right, that's a completely different type of question than what we've been looking at. But here's what you need to know. So just thinking about this, what kind of graph is this? It's a cubic, right? Now cubics tend to look like this, right? There doesn't actually have to be there doesn't have to be like a peak like this and a bottom like this, but there usually is on these. All right. Now, where would, in this case, the horizontal tangent line be? Well, horizontal line has slope 0, right? So there would be a horizontal tangent line here, and there would be a horizontal tangent line here. So there's potentially 2 of these. Now, this picture was just a made-up picture, so it's not, correct, but potentially there are 2 x values where this happens. There could just be 1 and there could be none. But potentially there are 2 x values that look like this. And what's special about them is their horizontal slope. But remember, horizontal tangent line that means the slope is 0, right? Slope 0 is horizontal. But the slope is the derivative. That means derivative is 0. So what does that tell us? That tells us that the method to solve this problem is to, step 1, find the derivative, which is going to be f prime of x. Step 2, we want the derivative to be 0. So you're not plugging in 0, you're setting it equal to 0. So you're going to set f prime of x equals 0. And then what you have to do is you're going to have to solve for x. All right? So this is a completely different thing than what you've been doing. The only thing that it has in common with the problems that we had up till now, I won't make those lines straight. The only thing it has in common with what we've done up until now is that you have to find the derivative, right? So, yeah, new thing. Let's try it. So, what's our f? F of x, they gave us. I'm going to write it different than they do. So, I don't like this. I don't like the way they wrote it there. It's 25x cubed over 3. I'm going to write that as 25 over 3x cubed. I like it that way better, but same thing. Plus 10x squared plus 10x squared plus 4x and minus 7. All right, that's f. Now, let's do step 1. Find the derivative. Okay? Step 1, f prime of x. Now, this is just power rule several times. So you have 25 over 3, and then what's the derivative of x cubed? 3x squared, right? By now you should be getting faster at that. You bring the power down in front and then subtract 1 from the power. All right, what about the next one? 10, and then what's the derivative of x squared? 2x. Right? You bring the power down, so you get 2x to the 1, but 2x to the 1 is just 2x. Third one, the derivative of 4x. You don't need the power rule there, right? What's the derivative of 4x? 4. You can do that just from the basic rule, right? We have the derivative of kx is just k. Ooh, scroll, scroll, scroll. Motion sickness. All right, back here. What's the derivative of minus 7? 0. Remember, the derivative of a constant by itself is just 0. All right, so you have the derivative. I'm going to rewrite it. So what do we have? I've got a 3 that can cancel with that 3. And that's about it. So I just need to rewrite it. So what do we have? 25x squared plus 10 times 2x is 20x plus 4. All right, that's step 1. I found the derivative. Now, horizontal tangent line means zero derivative. So we need to know where is f prime equal to 0. So all you're going to do is you're just going to say 0 equals the derivative. So 25x squared plus 20x plus 4. So essentially what you're doing here is you have to factor this. Now, I would honestly, if it was very easy to factor, I would factor it by hand. But this isn't that easy to factor. And so I would honestly just prefer to use a computer here. So it's 25, 20, and 4, huh? So I would just go to Wolfram Alpha, and I'd just type it in. 25x squared, was it plus 20x plus 4 equals 0, right? Just put an equal 0 on it like that. And I have no idea what I just did there. Looks like it made it go away. So I'm going to have to type it in again. Okay. No, okay. I want equals 0 now. Return. Okay, there we go. Oh, actually, look at that. It's only got one solution. Interesting, right? So it's only got one solution, x equals negative 2/5. And it factors into 5x plus 2. But x equals negative 2/5. Let's go back. So here I get x equals negative 2/5. So what I should have realized and didn't for some reason is that the number out front here and the number here, they're both perfect squares. And if you check that, you'll see that 5x squared is going to give you the 25x squared, and 2 squared will give you the 4. And then if you check the middle term, 5x and 2 is 10x, so it's going to be 10x and 10x, which is 20x. So this is what they call a perfect square trinomial. And so we could have known how that factored, but I just used a computer on that, and I got this answer here. Which, by the way, is telling me that when I said potentially there are 2x values, there wasn't, right? What it turned out that it actually looked like, when we got only a single answer there, what that's telling us is actually, close enough, is that there's at x equals minus 2/5, that it looks like this. And then right there, it manages to just be horizontal, just for one moment. So it doesn't have this shape, because if it did, we would have found 2 answers, but we didn't. We found 1. Okay. The main thing there was find the derivative, set it equal to 0, solve for x. Don't be afraid to use a computer to help you solve for x. That's what these tools are for. All right, next thing. Oh, you're killing me here. More applications, more applications. All right. Now, something that we talked about a couple of lectures ago when we defined the derivative, so you have to remember this. Recall when we defined the derivative at a point, like f prime of a, that we called it a few different things. We gave it different interpretations, right? We said, in addition to being the slope of the tangent line, it was also, or it could also be interpreted as the velocity or instantaneous velocity of an object at time t equals a. And that interpretation was only when the original function f was distance or, distance or position. Only when f of x is position or distance, then the derivative is velocity. All right, so you have to know that because they just throw it at you here, and they say a herring, that's a fish, swimming in a line has traveled S of t equals wow, they're getting in there. T squared over t squared plus 2 feet in t seconds. All right. They want determine the velocity at, oops, turned into an eraser somehow. Determine the velocity at t equals 3 seconds. All right, so that's the question. Right, the rest, whoa, really? How is that helpful? Why would you have done that? Cool. Rhombus. All right, determine the velocity at t equals 3 seconds. All right, so when you hear this, or when you read that, determine the velocity at t equals 3 seconds, your answer is going to be s prime of 3. All right, that's how you should interpret that. So they ask for velocity, they mean take the derivative and plug in 3. That's all. So there's nothing like theoretically difficult about this. It's just having to take the derivative. So you're just going to start with s of t equals t squared over t squared plus 2. Now, take a look at this. How are you going to take that derivative? Right? We did not learn how to do that derivative. We learned, look up here, we learned how to do derivatives when we were adding functions, when we were subtracting functions, when we had a constant multiplied by a function, when we had the derivative of a constant, the derivative of a constant times x, or the derivative of x to the n power. We did not learn how to do the derivative of something like this. And recognizing that you don't know how to do that derivative is the key. Okay? You're supposed to look at that and go, we didn't learn that. Don't make up a division rule. There was no division rule. Okay? What you're supposed to do here is this. What you have to do is make it look like what we do know how to take the derivative of. So you're supposed to rewrite this as using rules for fractions, right? If you have a over, oh, wait, what? Hold on a second. They are, No, 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 no. This is in the wrong section. This is in the wrong section here. Okay, hold on. Okay, you can't rewrite this one. This is just in the wrong section, okay? So, you can't rewrite it. I mean, you can, but you can't. All right. So when I said we didn't learn that, no, we really did not learn that, okay? This requires the quotient rule. Okay, so you're going to have to not do it right now. All right, and I don't know why that's there. That really should not be in here. I think they screwed up. Okay, let me do one that we can do, and we are going to have the quotient rule in the next video. Okay, next video. All right, but let's come back to velocity though. So here's a different velocity problem. So they say a car driving down a freeway has traveled S of t equals t cubed minus 6t squared plus 9t meters in t seconds. And they want determine when the car's velocity is 0. Okay, so here's what you have to do. Again, the key is recognizing that when they're talking about velocity, they just mean derivative of the distance or position. That's the key to doing this, okay? So for this problem, all you're going to do is you're simply going to take your position we want velocity. Well, what's velocity? Velocity is just the derivative, so s prime. Now, how do you do this derivative? Now, this derivative is no problem. This is just power rule. So the derivative of t cubed is 3t squared, right? Now, notice that we've been using x's, now we're using t's. That's not a problem. What we're doing is instead of doing ddx, we're just in our heads doing ddt. It's whatever the variable is, right? There's nothing special about x. So we're doing this derivative. So what's the derivative ddt of t cubed? 3t squared. What's the derivative of 6t squared? Well, again, you bring the 2 down in front, so negative 12t. And then what's the derivative of 9t? 9. There's velocity. Now, what did they want us to do? They say, determine when the car's velocity is 0. So they want velocity equals 0. So they want when is velocity equals 0. That doesn't mean plug in 0. Plugging in 0 would be time 0. We want velocity 0. So you set the velocity equal to 0. So it's just like that horizontal tangent line problem. You set it equal to 0 like this. And then we have to factor. Again, feel free to use a computer. I'm not, because this looks pretty easy. So I'll factor out of 3. Then if you divide both sides by 3, right, you can cancel it and just get 0 equals t squared minus 4t plus 9. Wait, is that going to work? I think we're going to need, do we need like the quadratic formula here? I don't know. Oh, because I didn't divide by 3. I factored out a 3, but not really, right? I should have divided the 9 by a 3 as well. Okay. All right. So this probably factors. So it's going to be, we're looking for numbers that multiply to 3 and add up to -4. And so that looks to me like -3 and -1 are going to do that. So we have t minus 3, t minus 1. From there, we have 0 equals t minus 3, and 0 equals t minus 1. So t equals 3, or t equals 1. So we have 2 of them, right? So what this is saying is, at time, t equals 1, what are we measuring in seconds? Yeah, we're measuring in seconds. So at t equals 1 second and t equals 3 seconds, the car has 0 velocity. Right? So make sure you pay attention to what variable they're talking about, right? Velocity is 0, not the time. So you're not plugging in t equals 0 there. All right, let me cheat, submit, continue, cheat, submit, continue. All right, one more and then we'll stop because I feel like I've been doing this a long time. Oh yeah, 1 hour, 7 minutes. Dang. All right, let's go. Last problem. I'm gonna actually work. All right. Got tired of the lag, which happens every time I switch to the browser. All right. Example. What x values make... Oh, no, that's not how to word that. Sorry. For which x values does f of x equal x cubed over 3 plus x squared plus 4x minus 10 have a tangent line slope of 3. All right, so this is just like the horizontal tangent line. So the steps are going to be basically identical except for one. So step 1 is going to be find f prime. We need the derivative. Step 2 is, well, the derivative is the slope of the tangent line, and we want the slope of the tangent line to have a slope of 3. So what we're going to do is we're going to set f prime equal 3. So just 3 instead of 0 this time. And step 3 is going to be solve for x. Okay. Now, similar to the other one we did with the horizontal tangent line, this is cubic, which means potentially the graph looks like this, right? And so potentially there's going to be 2 places where it has a slope of 3. Like there could be a place over here like that could be slope 3. And there could be another one over here where slope is 3, right? So the slope is the same at those 2 places. So potentially 2 answers. Right? So we're looking for the x values where that happens. It's not going to be that bad, I think. So let me write f of x. Again, I'm going to rewrite it like this. I like the constant out front. All right, so what's step 1? You just take the derivative. So 1/3, and then the derivative of x cubed is 3x squared. Then we have the derivative of x squared. The derivative of x squared is 2x. Then we have 4x. The derivative of 4x is 4. And then we have minus 10. The derivative of minus 10 is 0. Remember, constant by itself, derivative 0. So I've got the derivative is, I see that the 3 and the 3 are going to cancel each other out and leave me just with x squared plus 2x plus 4 for my derivative. Now, step 2, if we wanted a horizontal tangent line, we would be setting this equal to 0 for a slope of 0. But we have a slope of 3. So you set this equal to 3. So you go 3 equals x squared plus 2x plus 4. And you have to solve that. So you want to solve that. The way you would do it is you would subtract the 3 to the other side. So you have x squared plus 2x plus 1. What's going to multiply to 1 and add up to 2? Looks like this. Again, feel free to use a computer. So from this, I'm going to get that 0 actually just equals x plus 1. Which, that's going to say that negative 1 equals x. And that's going to be my answer, actually. Now, let's just, since this is the last one, let's look at it slightly more closely. So there was only one answer here, which actually surprises me. But it is what it is. So let's take a look at it and see why this is the case. So let's go type this into Desmos and look at the work. All right, so x cubed over 3. All right, Desmos. Oh, Desmos is already open. Oh, with lots of stuff I don't need. Go, delete, 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 delete all of this. Delete faster. Okay, what do we have? We have y equals, you don't need the y equals, what was it? It was x to the 3 over 3 plus, I already forgot, x squared plus 4x minus 10. X squared plus 4x minus 10. Okay. Now, how could there only be one answer? This makes no sense to me. I may have made a sign error. We're going to find out. So what we did over here was we found, we found that there was one answer here. This can't be right. Hold on. Okay, so that's, obviously going to be x squared plus 2x plus 4. Yeah, sure. We want the slope to be 3. Subtract that. So x squared plus 2x plus 1. That definitely factors into x plus 1 squared, which means x is minus 1 only. Huh. All right. Brain not working. We'll figure it out, though. So minus 1. So what they're saying is right here, the slope must be 3. But what's getting me is that if it's 3 over here, then it should be 3 over here as well. And so I don't know why, like what happened here. Let me just Look at this. X cubed over 3 plus x squared plus 4x minus 10. Was that it? I don't even know. X cubed over 3 plus x squared plus 4x minus 1. Was it minus 1? No, it was minus 10. It doesn't matter though. I mean, you can change that to a 10. Same idea. Okay. X cubed over 3 plus x squared plus 4x minus 10. And we need the derivative, so I'm going to ask for that. Right? So our derivative is going to be correct. X squared plus 2x plus 4. Right? And then when we do x squared plus 2x plus 4, and we want that to be equal to 3, why did I only get one solution? They only have one solution. All right, I do not know. My brain is not working why it is the way it is, but I'm not going to think too hard about it. I'm going to say -1 and then submit. Okay, well, okay, we did it right, but I convinced myself it was wrong, and then it took us a while to get there. Okay, well, anyway, potentially 2 answers, but in fact only 1 again. Okay, so sorry about that. Right, so what about this? Quotient rule. What about the quotient rule? So I do not know why this question is in here, but be aware that it is, because you're going to have to watch the next. You're going to have to watch the next lecture in order to get the answer to this. Okay, which so you just think about the next lecture as going with this one. And that's it for now. I'm going to do another video right now for you guys.